I'm Ryan. I'm the, I guess, person that came up with the idea and the team leader.
Hi, I'm James. I'm good at computer science and CAD.
I'm Gautam. I'm hopefully going to be like a web developer as well as like software and hardware.
I'm Zach. I'll also probably be doing software and hardware.
This is BioBalance. It's going to be a very high-tech aquarium. It's going to have sensors, and it'll probably also clean the sides of the aquarium, and also like do feeding and like feed the fishes and change the water. So anything that a human usually does to change, like to clean their aquarium, hopefully this product will be able to do that.
We have like pH sensors, water quality, water flow sensors, temperature, and like nitrate sensors, which we would connect to a web page where the user can see and monitor, as well as like control when we replace the water.
So our project is very hardware heavy. Besides the app that we plan to make, we plan to use a Raspberry Pi, various sensors like pH sensor, temperature sensor, water level sensor, and such. And then that all gets relayed to the software kind of aspect, to our mobile app.
Another unique challenge is also that we'll be dealing with water, so it has to be waterproof. It aims to automate a lot of the manual processes needed when you like own an aquarium, because it can be a pretty tedious task. So trying to automate all that and make it really easy, simplifying things is our goal.
Okay, so we've been doing a lot of website development. This week especially, yesterday we did a lot of progress with front end and back end work. We did a lot of the front end for our website. We have all the Firebase configurations working for our user auths and stuff. Everything about our app, you can like tap and it will kind of show you around there.
And even though there's so many like mechanical parts, one of the harder parts so far has been like connecting together all the sensors and like the camera. We've just been having some trouble like getting it running correctly. Mm-hmm. So because some of the sensors we ordered are like analog sensors, which means to use them on the Raspberry Pi we need a converter.
Yeah, the past like 3 days have been like a lot of progress.
Yeah, before that we wasted a lot of time on a camera. Like 3 whole days kind of just wasted.
Yeah.
But then eventually we kind of put it to the side, and then we made a lot of sensor progress. So we got the turbidity sensor working, TDS, total dissolved solid sensor working,
Salinity,
and electrical conductivity sensor working. So we use the electrical conductivity and temperature to calculate salinity through like some math. And then of course, like when these things work, we integrate them into Firebase, and then which allows it to be shown on the website. Good dashboard, shows all the data, it graphs all the data.
in real time too.
Yeah,
it's real.
Yeah, we do. Then we have a little like live stream down here.
Yeah. So hardware-wise, we have a windshield wiper. We don't have it mounted yet, but this will sit at the front of the aquarium. It's going to be wiping each side. This is the water outtake. It's going to be draining out dirty water when we change the water, because like you have to change the water for fish. There's going to be an intake one, but it's the mount that's going to hold it is currently printing. So got some nice fish decor. We're going to put some gravel at the bottom. And after that, for me, I'm just going to be printing the rest of the mounts for the rest of the sensors to make it nice and pretty.
Are you going to actually have fish on demo day?
We're thinking about it. We're like AquaSmart, buy some goldfish.
I think it was James was thinking we have like there's like a robot like hex fish that just like goes around. It's like a demo. But I think having like an actual goldfish would probably be better. Like we're like a.
It would be very cool.
We'll probably have these done by now. and we'll probably like be able to know how fast it goes and if it'll scare the fish.
I think we should be done.
Yeah. Yeah.
So we are mostly done with our project. We got it all wired up. Today we had some issues with like power supplies, so we got help from Matt to use a higher amp power supply. These two water pumps, which we kind of DIY to connect to the Pi because they're not really meant for the Raspberry Pi. One has the hose outside and one has the hose inside, so one takes the water out, puts it in a bucket, and one takes water out of the bucket and puts it into a tank.
So the feeder, I mean, we did this like a long time ago, but it just dispenses food. We changed the mount a little bit, so now it's a little bit more stable than the other one. This is the fish tank wiper. We got it to finally mount onto the fish tank, so all we gotta do is just run the code to make it work.
Yeah.
You probably will put them in the tank.
Yeah, well, we'll either have one of these or like an actual fish in the tank. We're still like deciding, but if it'll be an actual fish, it'll be like a small one, so it'll not have enough space in there to.
Okay.
Oh, it's gonna run so slow. It should be on.
Yeah, we
Yeah.
keep running with
Yeah.
stuff, so.
Yeah. Also, there isn't really a whole lot of
Surface area.
like space for it to get stuck because it's like pressed against the glass.
Which is partially why we want to use, fake ones.
Yeah. In the water.
Yeah, we're mostly done. It should just be, we got to test it. Obviously, the biggest thing is we haven't actually tested any of this in water. So.
Yeah.
But everything except for this is not water. I guess the server is not waterproof, but this is above water, so it shouldn't get contacted with water. All these sensors except for one is waterproof, but we put some silicone, so it should be waterproof.
Mm-hmm.
And everything else, everything else is waterproof now, or out of water. So.
Mm-hmm.
So, yeah, hopefully everything goes well once we add water. And I think that we're either going to do that first thing tomorrow or later.
I mean, you don't need a plan B, a plan A works.
Yeah.
So true.
His last word.
All right, welcome to AquaSmart, the future of self-sustaining aquarium solutions. So, what's the problem today? Well, aquatic ecosystem management today requires numerous manual steps, constant maintenance and measurements, and it can be very dangerous if fish owners are forgetful.
So this is our team. The four of us have a diverse skill set that allows us to create the most advanced, fully built out prototype that we could in the 5 weeks. Our unique solution is AquaSmart, our smart fish tank that uses sensors to transmit detailed data to an app, which can also be used to monitor a camera and remotely automate features like feeding, cleaning, and water changing.
AquaSmart uses a temperature, TDS, clarity, and electrical conductivity sensor to collect data. There's also a motorized wiper, food feeder, camera, and lighting. The backend program written in Python uses advanced calculations to achieve readable data. Users can select time intervals to automate feeding, cleaning, and water changing.
So to make our backend data look pretty, we need front-end technology. We're using Firebase Cloud as our database, which stores the sensor data and requests. Our website app fetches this data to display and graph it on the dashboard interface, as seen on the right, for easy use. Users can adjust feeding and cleaning or watch a live video of their fish from anywhere in the world.
So what are the other applications? Well, AquaSmart can be upscaled for large-scale aquariums, water zoos, and even help preserve endangered fish species. It can also reach into aquaculture or the farm-raised fish harvesting industry where efficiency would be maximized. Looking at a survey of 19 participants, 79% of people said that maintaining and managing a fish tank can be a tedious task, and 94% of people said that AquaSmart solves the issues, has a good purpose, and they would use it. In this pie chart on the right, we can see that the majority of people selected that they would pay $200 to $300 for the AquaSmart tank.
So in summary,
Our team has created a self-sustaining and autonomous fish tank that can show detailed sensor data on all your devices anywhere around the world and can automate tedious tasks like feeding and cleaning. We plan to expand this project for larger use cases and include even more features in the future. So we would like to thank everyone at the CPSE program as well and give a special thanks to the people listed on the screen.
For more information, visit aquasmart.app. Again, thank you.
Thank you, AquaSmart.